Well, good evening, good afternoon, and good morning to everyone joining us today from wherever you are. It's an absolute pleasure to welcome you all to our third Global AI London meetup. Now, today, we have got an exciting line of speakers, right? We have incredible James, who will be talking about, we've got a slide here just giving you the agenda, what's going to be happening.
There we go.
Yeah, so we've got the brilliant James Bentley, who is a consultant with Advancing Analytics, that'll be giving you a beginner's guide to agentic frameworks. Now, this is really key because everything that we are looking at and everything going forward to next year is all about agentic frameworks. There's a huge buzz around agents and how we implement agents to achieve something more spectacular than what we've seen this year. So that's a real useful, it's going to be a very, very good talk to attend. And then we've got the amazing Toyosi, who's also a consultant at Advancing Analytics, and he's going to be talking about the RAGBuilder. Now, that is a really exciting topic as well. Everything that we've done in terms of Gen AI this year, right, has been about RAG. So Toyosi is going to introduce what RAGBuilder does and how we can really simplify the RAG development pipeline. So this meetup is all about connecting, learning, and engaging, and hopefully you're inspired by the presentations we have today. Please feel free to ask questions, share your thoughts, and provide feedback. I can't wait to dive in. So grab your coffee, grab your tea, grab your water, whatever you need to grab, and let's dive straight in.
Yeah, thanks, Gabby. Yeah, so before I introduce James, just one quick thing. If you're joining us from YouTube and LinkedIn, you might not be aware that we have a meetup page. So I will share a link to that in the comments. But for anyone that's got a phone handy, if you just scan the QR code, it should hopefully take you straight to our meetup page. And that's where you'll get all of the latest updates on when we're doing these. Sometimes we do them remote, sometimes we do them in person. So it's always good to have a follow along. And with that, I will introduce James to the screen.
Hello.
Hey,
Hello.
James.
How you guys doing?
Good, thank
Good.
you.
I can't wait for your talk anyway, James. All about AI agent and introduction. So can't wait to hear you talk about it.
Brilliant. Yeah. I mean, as you said, Gabby, AI agents are definitely like the next big thing. Like first it was LLMs and AI in general, and then there was like, RAG and all that really took over mostly this year. But now looking forward, 2025 is probably going to be the year of agents if we haven't already started on that wave.
I don't know whether you've managed to catch all the news roundup by tech organizations out there about James and Tori, but they're all talking about agents and how it's going to be implemented into everything that we do, right? So there's a huge hype and buzz around it. But I don't think it's a buzz because we're already doing it here at Advancing Analytics.
Yeah. Yeah, we've already done prototypes. We've already pushed things into that POC and even some level of agentic tools going into UAT environments. Although we'll get onto what does an agent or agentic really mean. But yeah, it's really exciting, and it's definitely something that we're putting like all of our weight behind at the moment to really keep at the front of because it's moving so quick. And develop it as fast as we can.
Cool. Take it away then, James.
Brilliant, thank you. So I mean, as Gabby said, if you've been following Microsoft Ignite this year, even the Databricks Summit back in summer, there was already a bit of rumbling about agents back then. They were already starting to be announced as major players at Databricks, particularly in the Mosaic AI space. And then if you watch Ignite this year, you can't have missed just the absolute heap of agentic stuff going around. AI Foundry is now being pivoted towards agents. Agents are being incorporated into Copilot for things like SharePoint to really make everything as accessible as possible. But when you think about it, even just thinking a couple of years ago, we had all of these new terms starting to crop into our lives. Prompting, fine-tuning, vector stores, a RAG, whatever a RAG is. And these are terms that, basically no one would have used even a couple of years ago. And now, as AI engineers, anyone in the data or tech space, they're commonplace every single day. And now, of course, we have agents, which is a bit of a nebulous term. As I said, it's one that's growing very rapidly. There's lots of development going on in this space. Pretty much every single week, there's a new framework or library or something out to do with agents. Every single month, the entire face of what this big area of data and AI means changes completely. And that means that, they're pretty hard to pin down what actually is an agent. Well, as a very high level general idea, you can sort of break agents down into three different areas. First one is autonomy. So agents are systems or frameworks where LLMs can make their own decisions, but what their own decisions are and what those decisions are changes quite a bit. Agents tend to be goal-oriented, which means they pursue specific objectives which they're trying to solve, which is normally, answering a user input or meeting a predefined end goal via whatever means they need to. And also, agents tend to improve over time, so especially iteratively within a single process. So a user input to a user output, they will improve their answer iteratively rather than just going straight through or going straight through and then feedback learning. That feedback learning should occur within that input to output stretch. But as you can see, there's a lot of asterisks all over the screen. And that really starts to tap into everything is moving so quickly. What one person says is an agent, another person might not. When someone says, well, this AI is making its own decisions, someone else might say, well, aren't you just giving it 3 or 4 different options to choose from? That's not really making its own decisions. And that kind of leads us to this problem of using the noun of agent, because that kind of implies, is the system an agent? Yes or no? But a lot of different questions can come out of that. As I said, is it making its own decisions? Can it handle tasks without explicit instructions? Can it overcome obstacles? Can it do that whole iterative improvement and autonomy? And although these seem like quite simple questions, in some situations they can have very subjective opinions on whether, as I say, have you essentially told an LLM how to do this ahead of time? Have you just given it a bunch of options, or is it learning for itself and acting for itself? And you can see this when you start to think of what we might, at least now, begin to call traditional AI and LLM models. So we've got things like traditional. I say traditional, meaning like a year or two ago. But traditional chains, which are more like DAG style workflows, quite traditional systems that we'd already be quite familiar with. If you have your input, you've got action A, B, and C, which you've predefined, pre-written, hooked up in a very specific order, and it gives an output on the other end. These are not very autonomous because they're just doing what you've told them to do, no more, no less. They are goal-oriented, I suppose, in that they are achieving a goal, but that goal is one that is railroaded. They only have one place to go, they only have one path to take, and they don't really improve. As I said, they just do what you tell them, no matter what. And if they don't err in the middle, then they will produce something out the other end. You've then got prompting techniques. So, for example, you are an AI who imitates animals. When given an animal type, make the noise of that animal. This is very goal-oriented. It can kind of shift what it's doing to meet the goal. But again, it's not particularly autonomous. It doesn't particularly improve. It's only really doing one thing. And then structured outputs. This is where we really start to get onto what I think of as the border between more traditional AI systems and agentic systems, because structured outputs, again, they can be quite goal-oriented, but the key point here is that level of autonomy. They are starting to think for themselves, depending, for a given value of think. They are starting to think for themselves, and they are starting to give outputs which you can then do stuff with later on. So you can decide. So the AI is making a kind of decision, but you are then deciding what to do with that decision. So the example I've given here is the sentiment of this text positive or negative? Depending on the decision that the AI makes, you can then do something different with that because it's in a structured output, which is then very easy to read using code. And so this really opens up that idea of, where do agents and agentic frameworks, as I'll get into in a second, sit? So you've got the bigger layer of language models. These are just LLMs, you know. So this is your most basic interaction with an LLM possible. You are sending a prompt, a question, whatever it is, just a single straight prompt into it, and it is giving you a reply. And that's pretty much the extent of what we might classify as just language model interactions. One step further down, that's where we have things that you might be familiar with, such as RAG. This is what you might call compound systems. So this is a bit of a step above language models. We're starting to modify what we're putting into the language model with external data, again, especially in the context of RAG. We're taking data which is unrelated to the LLMs, you know, and we're giving that to the LLMs and being like, okay, make a better answer using this. And that's where the whole compound aspect comes from. You know, we're using LLMs, we're also using other stuff to make our answer. And within that, we have agents and agentic frameworks, which is where we're, apologies, can I have a sip of water? Which is where, you know, we're taking things like RAG, and we're also taking potentially functions written in code, and we're potentially taking other tools such as API calls and other LLMs to reflect and think for themselves. And that is, again, making better answers based on that entire mix of things going into it. So you see we're already moving well away from those very basic language models to begin with, and we're starting to build in more and more layers until we're getting to this sort of agentic level. And you may notice here now that already I'm starting to use this term agentic frameworks more than agents. And that's because, as I said, you know, using the noun of agents is quite an issue because, you know, as I said, where do you define agents as starting or stopping? But if you call something agentic and use the verb rather than the noun, then we can start to have different levels of where agents start and stop. So something might have a couple of agentic aspects to them. It might be a little bit agentic, or it may be incredibly agentic. You know, this is a full system which is entirely autonomous, entirely reflective and improving, and makes all of its own decisions. So we can be anywhere along that scale. And there are multiple different ways that we can achieve this. The 5 main ones are routing, reflection, tool calling, planning, and multi-agent. As I said, you know, this is an incredibly fast-moving space, and this is changing all the time. So this is just a sort of a snapshot of where we are at the moment. Some of these are starting to fall behind, some of them are becoming bigger, and some of them are starting to merge and mix. So let's have a think about how do these 5 different methods work. So the first one, which is probably the least agentic, is routing. And this is essentially what we already touched on earlier with structured outputs. So you can already do this just using things like LangChain. You can ask your LLM to apply in a JSON format, and you can pass that as a JSON output, and you can programmatically do stuff with it. So exactly as we saw earlier, routing might be, please define this as positive or negative in a JSON format, take that as a structured output, and then you can just use vanilla code, Python, C#, whatever, for if my JSON output was this, I want to call this function, and if it was that, I want to call that function. And this is really basic stuff. You may already be doing this. It's really useful in stuff like guard railing, which we might go on to later. And it's a very sort of basic entry level to these decision-making LLMs. Possibly the next step up is reflection. So reflection may look something a bit like this. So if, you know, your input would be, write me a paragraph about this, about agentic frameworks, for example. And part of your flow, your chains, your system, whatever, might have this step where you send this off to a different model. It could be a different instance of the same model. It could be a different model completely with different specialities and weightings and capabilities and all that. And you'll say, here was the input question. Here was the output. Please, can you improve it? You know, can you correct mistakes? Here is access to a vector store. Please, can you use what's in the vector store to proof check it for inaccuracies, make suggestions? And you might do that once. You might do it loads of times. You might even then have a third LLM who decides if it's good enough yet. So you can see how these things really start to spiral quite quickly. And then the output of that, you get yes, certainly agentic frameworks are, and you have a paragraph which should be better than if you just said, write me a paragraph, it wrote it, it outputted it. This one should be better because it's been checked and rechecked and improvements have been suggested and so on and so forth. We then have tool calling. So tool calling is probably you may probably have heard a lot about multi-agents, which we'll get onto in a moment, and they're definitely the ones with the most hype at the moment. But I would say that tool calling is the one that is most sophisticated and probably the most widely used. So tool calling might look something like having an AI chatbot and you ask it, what's the weather like in London? Now, LLMs are pre-trained. They don't really know anything current. And so it might try and hallucinate and make something up. Or if it's agentic, it may have access to tools, which are essentially deterministic code, which the LLM has a description for. It has, as I've sort of very high level, for the sake of just sort of understanding, it may have inputs, as I've shown here, and returns, and maybe a little description so the AI knows what the tools it has available will actually do. And then the AI will simply call that tool. And this is a very simplified function, but it may look something like this: of call weather API is your tool. It runs a Python function that maybe goes off to do a request somewhere, gets a JSON response, and returns just a payload or the content string of what the weather is currently like in London. The LLM can then see that, summarize the response, and output the response to you in a more natural language way. So, but this doesn't have to just be, a weather API call. If you have things which you need to run 100% certainly, you may have very complex math functions which you want your LLM to be able to interact with and answer for you. You could provide them as tools. So if you ask your LLM, I'm working on this data, here are some of my inputs, what's the insert very complicated math equation for it here, then your LLM will maybe be able to take all of your inputs, run your function using a tool by passing in the correct parameters, and then it'll get an answer, and then it'll be able to phrase it nicely for you. And there's not really a limit to how many tools you can have. Obviously, practically there is a limit, but you can have lots and lots of different tools. All of them have different descriptions, inputs and outputs, and your LLM can sit there and it can decide, which tool do I want to call? Okay, I've got a response. Do I need to call another tool? Is my answer ready? So you can really start to make them very general in this respect. Moving on quickly to planning, because that's quite a good segue. This is not so much methods, but more just a key overarching theme that comes up in most agents increasingly now. You may see when you start playing around with them, especially on things like LangChain or in Databricks, agents tend to have what's called a scratchpad or some equivalent of a scratchpad. And that's essentially where the LLM can read and interpret the task, and sometimes there may be multiple facets to it. And we've seen sort of multi-stage reasoning in chains before, but in this case, the agent is actually deciding what these stages actually need to be, and it will jot them down on the scratchpad, which is essentially just a really long string that kind of follows the agent throughout the whole process. So in this case, write me a story about the world's largest tree. Your agent may take that in, and the first stage might be the planning stage, where it goes, okay, I need to decompose the task. I need to find out what the tallest tree is. I need to write a plot. I maybe need to evaluate it, going back to previous methods we discussed earlier. Maybe need to evaluate it and make sure that this is a good story and see if I can improve it. It can then go through its scratchpad. It can begin to do these tasks, jot them back down on the scratchpad, so it's keeping track of what's happening. It may call tools to do that. It may just call extra iterations of the LLM. And then it might do some reflection on the end, and it will keep going through that until it is ready to output something at the end. So that's where the planning aspect comes in. That scratchpad is quite a sort of key concept to understand. And as I say, it's more of a theme now that follows a lot of agents through their whole cycles. And finally, I'll get onto the big one, the one that everyone is really hyped about at the moment, and that's multi-agents. So this is essentially a great one to get to as the fifth one, because it is all the other ones, but multiple times. So you can see here, I've sort of done, again, a really high level outline of what an agentic framework might look like in terms of assessing a policy, maybe for an insurance provider. All of these dark blue ones are then sub-agents. They are their own agents. The lighter blue ones are sort of tools or deterministic functions. So you can see we've got a user proxy. This is the sort of the orchestrator agent, the one that takes in the question and decides which other agents to then call. And all the other agents have personas. So, for example, the SQL engineer will have a persona of you are good at writing SQL in this language when given a task and maybe a database schema, write a SQL statement to go and get the data. When it's done that, it will then pass it on to the QA engineer, whose persona will be you evaluate SQL in this language. Evaluate it for errors, common mistakes. If you're happy with it, run the query, which it will then be calling a tool to just shove some SQL code into a Python function or a SQL endpoint. that query will run. It will return data or it will return an error. The SQL engineer can then assess that data. If it's happy with it, it can pass it back. If it's not, it can have another crack. So you can see even in that short corner, we've already got tool calling, we've got reflection, and we have multiple agents working together. And that's what's called a maker-checker pattern. So we have a maker and we have a checker. So you can see even in that small corner of this multi-agent framework, we've already got loads of different methods going on. And that's not to say anything of the rest of the multi-agent framework. So you can see how these things scale really quickly. So I just want to quickly touch on the benefits of agents. It's all great talking about what they are and why they work, but why should we use them? As I say, performance. So agentic frameworks can, the keyword being can, outstrip improvements between LLM generations. So for example, it was found that an agentic system using GPT 3.5 models was able to outperform GPT-4 on several benchmarks. And that's really supporting this shift that we're seeing, especially now, away from making LLMs bigger and bigger as they begin to plateau in performance, and actually shifting back to small language models or existing LLMs. But instead of just improving the actual model, we're just using loads of them together in more clever ways, which is how we can boost our performance rather than being quite wasteful in just training massive systems which take loads of energy. We can then focus instead on smaller ones which work more efficiently together. In terms of autonomy, these agents can fix their own mistakes. They can overcome issues and obstacles. I touched on earlier, a SQL maker-checker pattern can try and make a SQL code. If you just had that as a single LLM, it would try it, you get it back, it might not work. It's almost like a bit of a meme that AI agents are AIs are good at writing bad code, but not necessarily good at writing good code. But maker-checker pattern, that kind of goes away because you have it have a crack at making some code. You can then evaluate it, you can see how it performs, and you can then iteratively improve it until you're ready to output. So it's multiple LLM calls, but it's all within one system. So it can overcome some issues. And of course, they can make novel decisions in the face of these issues. And finally, flexibility. You get the creativity of LLMs to phrase things differently, to summarize things, but you can also use tools to incorporate the deterministic predictability of deterministic code, which is great. So when should you consider them? Well, as always, it depends. Agentic systems are great for if your use case is complex, dynamic, or temperamental. You really want to take advantage of that creativity, that ability to overcome issues, to sort of be quite dynamic about how they function. But they're not so great if your use case is imperative. If it's really important to make sure you definitely get it right, if you're on a budget, or if it's looking to be production grade, because these agents, accuracy kind of drops off the more agentic it becomes, because you're giving more freedom over to the LLMs. They can make mistakes, they can go off on their own little tangents. So if you really need something to be incredibly specifically done, you're probably better off using more traditional compound methods, unless you're willing to put in a lot of tools for the agent to use. Agentic frameworks can also become rather expensive, and the latency can increase quite a bit, because when you think about it, you're doing a lot more LLM calls. So you may be able to have cheaper LLMs working together, but you need to consider how many more tokens you're going to have for all of these increased levels of interaction. And of course, production grade, as I said, this stuff is changing all the time. You can go away for a couple of weeks, you can come back, the entire landscape's changed. So although there are some frameworks where you can start to consider productionizing these things, if you want to stay at the very cutting edge, you have to be aware that these things will change rapidly. Things might break. Some things may be deprecated after mere months or weeks even. So you have to be ready for that, and you have to know what it is you're actually planning for in the medium to long term. And finally, I just want to touch on that performance-driven one. Yeah, if it's performance in terms of latency, then agentic frameworks can take a lot longer sometimes than compound systems. And in terms of accuracy, they can drift or they can be far more accurate depending on what your actual use case is and why you're using them. So just some final key points to sort of be wrapping up on. One that I haven't really touched on but really wanted to fit in somewhere, so I just shoved it on here, is that other models are available. And what I mean by that is when you consider, especially in multi-agent frameworks, there are loads of different personas going on. There's an orchestrator, there are code generators, there are checkers and summarizers. You don't have to use the same model for all these because different models have different benefits and they also have different costs. So things like guard railing, you might want to use something like Llama Guard or GPT-4, really good at reasoning and detecting malice in inputs. Summarization doesn't really matter as much. You can use something that's a lot smaller and cheaper, like GPT-4 and Mini, or like your favorite Llama models, and things like the user proxy that requires a high degree of reasoning and tracking lots of things, what's going on. So you might want to use a really big and expensive model, but one that has a very high level of reasoning. In fact, Microsoft specifically pointed out in Ignite that O1 is perfect for the sort of the user proxy orchestrator persona. And that allows you to really tailor latency speeds from your models and also cost implications as well. Maker checker patterns. Again, these are a really big part. I can't stress how big these are in terms of agentic frameworks. The make me a thing and improve this thing is something that will come up in pretty much every single agentic framework that you'll work on. There isn't like, really tiny work. So this is probably going to come up, and it's really important to understand that, these do rely on two different LLMs. You have to make sure that you have things like iteration limits, so they don't just go off the rails arguing with each other. Again, at Ignite, they told an interesting story about how a maker checker pattern they had took 7 to 8 minutes to run, and when they looked into it, it was about like 50 different just back and forth between this maker and a QA model just arguing with each other. So these things are important to be aware of, but they're very important patterns to understand. And finally, agents are a pattern, not a technology. So the definitions are very flexible. The methods are mix and match. You might have planners and tool calling. You might have reflection. You might not. You might have a single agent. You might have lots of them. And that's okay. That's completely fine. This is a very rapidly evolving space, and it's up to you to decide, what do I need to complete this job? You don't have to stick to a very rigid structure, or you don't have to go with multi-agent because they're the best and they're the biggest. Sometimes the smallest are far better and more cost and time efficient. And you may already be using them. As I said, especially things like routing and reflection. These have already been around for ages. It's just they've started to now be rolled into this more general concept of agentic frameworks. But people have been doing this sort of stuff for ages. So how can you get started? There's some great libraries and frameworks out there. LangChain is where a lot of this stuff started. It's like the flagship for open source LLM development. They are now developing LangGraph, which is a more graphical approach to building agents and agentic flows. Really worth checking out. They're probably the closest. They're probably the frameworks that are closest to production grade at the moment, and they're really evolving really quickly. Swarm is an OpenAI-backed library and framework. It's more in a sort of alpha stage at the moment. It's more just for people to learn about multi-agents and where they're going. So definitely not for production, but great for education and learning what's going on here. And then Crew AI and AutoGen. These are two other libraries as well, which are great for multi-agent development. They both have their own benefits and drawbacks. AutoGen is Microsoft backed, Crew AI is its own thing. But both definitely worth checking out if you're definitely after multi-agents, and you know that's definitely what you want. And finally, I believe this is the last slide, which is good timing. Two other things I just wanted to mention are Azure AI Foundry and Databricks Mosaic AI. And these are things I mentioned right at the beginning of this. And these are both announcements this year, really, of how you can get started making agents in either the Microsoft space or the Databricks space. AI Foundry is a great low to no code solution for developing agents. You may already know it as the AI Studio, which has kind of evolved from then. And this Agents Playground is coming out very soon, I believe, off the back of Ignite, allowing you to easily play around with tools and agents and seeing what you can do with them. Mosaic AI is similar. It's in Databricks. You can write your tools very easily using Python code or SQL code. And yeah, you can get cracking with them. And Mosaic provides loads of great UI solutions for managing how your agents are doing, evaluating them, seeing timings on them and things like that. So definitely worth checking out as well. But you do need Unity Catalog for that if you're going to go down that route. And so that's pretty much it. We do have a blog post out at the moment, which covers a lot of this stuff as well. If I went through any of it too quickly or you don't get time to ask a question, and keep an eye on our blogs and YouTube channel as well, because we're going to have loads of more agent stuff coming out in the near future.
Thank you, James. That was good. That's really good. I really enjoyed that. James, I've got a question for you. You presented lots of frameworks there. Have you got a favorite and why?
I like tool calling because I think you have a lot more control over it. The ability to sort of write your functions exactly as you want them to be is really beneficial, I think. But of course, multi-agents are definitely growing, and I think they're the ones that have the most potential. So we'll see if that answer is still the same in a couple of months' time.
Cool. And in terms of, you spoke about how the ability of agents being totally autonomous. How would you balance autonomy with accountability when you're implementing AI agents?
Yeah, so that's definitely a really important factor. I mean, I think evaluation is definitely your first step. You need to make sure that your agents, whenever they're answering your questions, they've been evaluated against a sort of a gold standard, the classic evaluation things that you would do with LLMs already. You need to make sure that they have a history of being able to answer questions properly. And also human in the loop, especially upfront, you need to be able to build that trust in what your agents are doing. This is new tech, it's moving really quickly, and you need those humans to be able to assess and certify that they're correct before you then start to release them into being fully autonomous entirely by themselves.
And, we talk about guardrails. There's so many different options in terms of, how we implement guardrails, like this Llama guard, for example. Would you fully trust it, or would you still have guardrails such as Llama guard as well as human in the loop? What's your opinion in that then, James?
So yeah, it's definitely a very difficult one to be 100% certain of, because you can't be entirely certain with any of these things. I think the best approach there is belt and braces on inputs and outputs, having very high level reasoning models as your guardrails, and maybe even a second guardrail, for example, Llama guard, which is fine tuned to spot these sorts of things. That's brilliant. But you also want to make sure any data it's accessing, the AIs only have access to the data they need. And you might even then want some output passing at the end. For example, previously we've implemented PII passes. So if the AI has somehow managed to pick up PII, like personal information, you then clean the output using purely deterministic code, which works to get rid of that, so that just in case anything has gotten through, you can then scrub that out. And again, limiting what the AI is capable of doing. If you're giving it access to a database, don't let it drop tables just in case. You should be scrubbing out drop table commands, but in case you haven't, it will just error, and that's fine.
Cool. Thank you very much for your time tonight, James. Thank you for joining us on Global AI London. And I guess this brings us on to Toyosi, our next speaker.
Hello.
Hey, Toyosi, how are you doing?
Hey, thank you. I want to just thank James, because that was very insightful. I learned a lot about the agentic framework as well from him. So hopefully this part of RAG can actually also be a supplementary to the agentic framework, especially for evaluation purposes.
Cool, Toyosi. Take it away. I'm also very keen to hear this part of the talk tonight.
Amazing. All right, welcome everyone. So today I want to talk to you about RAGBuilder. The main focus of RAGBuilder is simplifying the development and evaluation of RAGs. So what's on the agenda today? So we've got the introduction, why RAGBuilder diagram, demo hands-on with RAGBuilder, and then useful links. And then at the end, if you have any questions, please follow through with them. So for the introduction, I want to just go through what RAG is. As we already know, RAG is for combining information retrieval with generative power of LLMs. It excels very well in Q&A summarizations, and we've seen them become very popular in industries like private industries. We've also looked at challenges in building RAG pipelines. So we've noticed that there was a lot of complex and difficult problems we were facing, and we were also having difficulties in evaluating the metrics as well. This is where we then decided to utilize an open source endpoint, which is a RAGBuilder. RAGBuilder helps us automate RAG pipeline configurations and evaluation. It also helps us log configuration changes for easy comparison and also optimizations. We also noticed that it was trending on GitHub and ranked number 11 about a week or 2 weeks ago on GitHub. So why do we use RAGBuilder? On the left-hand side, we've got code that can be generated or manually typed in. However, what RAGBuilder does is simplifies this code, meaning that it generates this code for us, and we can easily copy the snippet and then paste it within our code development cycle and change it however we feel fit. Also, another reason why is that sometimes creating a RAG can be very difficult because of all the different parameters you have to consider. So take, for example, the following: 3 different chunk sizes, 3 different chunk methods, embedding models, etc., and you get about 2,187 possible combinations. And if you assume that each of those evaluations takes about 10 minutes, that's approximately 15 days of continuous trial and error. Where RAGBuilder excels, it simplifies this by providing multiple configurations and testing throughout the phase. So you can easily set those different configurations you have and have a single UI that provides all the different combinations from there. So second, another reason why RAGBuilder, smart optimizations. Like I mentioned earlier, it removes manually trying to endlessly add configurations, smart hyperparameter tuning to reveal the best setup for your data as well. Sorted predefined templates. So those are the templates that are already known to be one of the best ones for building RAG configurations. And it also helps us test against data with minimum setup time. We also have customizable granular controls. So like we've mentioned about chunk sizes, embeddings, re-ranking, etc. It helps us smart hyperparameter tuning and reveal the best setup for the data you've provided. So I wanted to then show you a diagram of exactly how the RAGBuilder works. We've got some files which we ingest into the RAGBuilder. The RAGBuilder has different configuration parameters, like for example, the chunking strategy that we want to use, embedded model that we want to use, the retriever, re-ranking, and also some prompt templates if you've got that and provided them. It also helps with evaluation, which is not displayed on this, evaluating using RAGAS, which is very important for testing how well our RAG setup is compared to other setups. What I will now go on to is walking you through a demo on the hands-on with the RAGBuilder. So if I just go to my VS Code. So here we've got the RAGBuilder cloned from the repository. We've got some things here where we've got our documents where we can store documents or PDF and text files. We've also got our .env sample, which has all the configuration variables that we want to set. So the OpenAI variable, if you have a minstrel variable API key, you can use that too. We've also got some other things like Google Cloud Project, and we've got Neo4j if you wanted to use Graph RAG as well. Another thing to showcase is the RAG test data, which we'll come on to later on after we've set up our RAGBuilder. An easy way to set up your RAGBuilder is just by following this simple command, which is docker compose up -d. This sets up our docker compose and allows us to run locally the RAGBuilder. Once that's running, since I've already got an instance of it running, it's easy as opening it up in our web browser, and we can see the different performance dashboard. Here we've got our RAGBuilder. Let's say we wanted to create a new project. A new project can then be selected with the description. So for testing purposes or development purposes, let's say document Q&A. And one thing about the source data is we can have different types. So let's say we wanted to use a website, we wanted to use our documents. We can do both of these options. So for this example, I will follow through with the technology review.com, etc., etc. This is going to be our source data. And what we can then do is use predefined RAG templates, or we can also create custom RAG configurations. If we use the predefined templates, one thing to note is we also get the perform data sampling. So if our data set was huge, I believe about 5 MB or more, it will tell you to use a perform data sampling. We also have a perform data pre-processing, which allows us to remove stop words, strip tags, strip punctuation, etc., etc. For the case of this demo, we'll just leave these two options unchecked. First, I want to go through the use predefined RAG templates. Within those options, you can see some sort of predefined RAG templates that are already used within the industry: contextual retrieval, graph RAG, hybrid retrieval. However, these two, you need to have Neo4j loaded and set to true, and you also need the API key and the Neo4j database name. However, for this case, since we are not going to be working with graph RAG, we'll uncheck these two. We'll also uncheck the hybrid RAG for now. However, it's showcasing that these are all possibilities. So if you wanted all these combinations, you can also have them within your testing facilities. We'll change our embedding model and set it to the AI toolbox, which we already had predefined already. We'll also change the Azure OpenAI for the LLM, set to GPT 4.0. We can do the same thing here for the RAG evaluation settings. What we can now do is then also change the embedding model for the RAG evaluation model. We also have the Azure OpenAI, and we can change that to GPT 4.0. Within advanced settings, this is where we can generate the evaluation data set either automatically or manually. If you already have your own manual data sets, as James mentioned previously, you'll be able to create that. You could upload that by yourself with your path to your test data. However, since we wanted to generate it automatically for us, we can set the test size to 20. That means it will have 20 rows. We then change the embedding, and likewise for the critic LLM and the generator LLM. We will be using the same model just for simplicity's sake, and also the same embedding model as above here. Next, it will confirm all our selections, and then we can click confirm. For the sake of the demo, we won't wait here because we might be sitting here for a little while, and I'm sure you guys do not want to see a screen of it showing it's completed or not. So if I'm to go back to this home dashboard, we can see our successes and our failed pipelines. what we can then do on this project is we can view let me zoom in for you to be able to see better. We can see the status, the description, which is the name we set, the source of the data, the configuration, the run configurations that were set or predefined. So this is something that you would set by yourselves for your configuration for this pipeline. We can then see the disabled options, what has not been selected, the timestamp when it was ran, and then within that we can see the results. Within the results, we have the different selections of configurations where if you can remember, we selected the contextual retriever, query rewrite, etc., etc. And we can now view some information about it. For the contextual retriever, we can see that the number of tokens, and we can go into it more for further details. We can see the evaluation metrics within this contextual retriever, and we can see how it's the RAGAS is testing for answer correctness, faithfulness, answer relevancy, etc., etc. One thing to note is it then gives us the average of all those within the answer correctness, the context precision, context recall, and we're able to then determine per 1,000 queries how much it would cost. So this would cost about $27 or $28 per 1,000 queries. Another good thing about this is, which I was mentioning before, was the code snippet. You can view your code snippet, which means you can change or modify. Let's say you're happy with this RAG setup. You can now take this RAG setup as it is and copy it within your Visual Studio Code easily as just copying to the clipboard. Within this, you also have this chat functionality, which you can now chat with that RAG configuration and say, let's say, for example, what is the summary of this document, and within it we can already see the information and the retrieval of our question, and which is very useful for testing it out. So let's say, for example, we had the same hair, and we wanted to test out this question and compare the two answers. And this makes it very simple and easy to work. However, with this, we can see there's already a failed response, meaning that maybe there was some certain things that weren't working too well within this. If I'm to go back to the Visual Studio Code now, I can see the RAG test data. This is the RAG test data that the LLM, sorry, not the LLM, the RAGAS was using to test for truthfulness, correctness, and so forth. So we can see here the question, the context, the ground truth, the evaluation type, metadata, and then the episode done. Another thing we can do if we wanted to test for documents, we can also use the documents LOF and then use that. The Neo4j allows us to also set up the database for GraphRag. And then the evaluation is where you can play around and change the pricing if these prices have not changed since. So there's a lot of functionalities you can change by yourself to ensure that you get the most accurate results. And I believe that's me wrapping up. Thank you. Let me go back to my PowerPoint. Display. Right, so what are the useful links? Some of the useful links are the RAGBuilder.io. We've also got the documentation where you can understand or find out more about the RAGBuilder, how it works, the intricacies, and any further information. You've got the GitHub repo where you can find out more about RAGBuilder, and you can also pull and clone the RAGBuilder. And you've also got the blog, which we've written about RAGBuilder. Hopefully, this will all help you in your journey with RAGBuilder. If you have any questions, please do let me know. Thank you.
Thank you very much, Toyosi. Thank you for that. I have one question.
Yes.
So when would you recommend RAGBuilder over any other framework?
So the main use of the RAGBuilder is to evaluate your RAG. And most of the time, I would recommend it at the start before you've even started productionizing, just so that you can first test which configurations for your RAG are the most optimal before you go into production, and then go into further configuration parameter tuning.
Got ya. So almost like AutoML for
Yes, it is almost like AutoML. Yes, and I feel like that's the nature of where RAG is going, is to try and find a way to simplify all the different variables that are coming in and out as fast as possible.
Sorry, I came on mute. James had to kindly remind me that I wasn't mute, and I was saying, Toyosi, I enjoyed that talk quite a lot. And Tori has stolen my question, really. I was going to ask the same question. Great minds, Toyosi, but I've got another one, perhaps. I think what I saw is the ability for RAGBuilder to really, like you showed, there's so many different chunking strategies. There's so many different back to databases. There's just so many variables to optimize and tune when you look at a RAG framework. And we know RAG architectures are getting more and more advanced and even more complicated, right? So I think what you've just demonstrated there, that if somebody wants to get started with RAG, play around with RAGBuilder, understand what it can do, because your RAG architecture will be different for every use case as well. The way you chunk for one use case will be very different to the way you chunk for another use case, right?
Yeah. Yeah, that's definitely a big part of it. Also using different LLMs, which different users might use. It's a good way to compare which one is actually effective for your data type.
Yeah. And we know it takes ages to swap in and swap out of LLMs, and this just shows you can do it so seamlessly, right? I like it. I think like what Tori said, right? It democratizes for people trying to get onto the RAG wall or trying to implement RAG. It's very, very easy.
Yeah, it definitely makes it a lot easier.
Yeah. I was going to ask just one last question before we wrap up. Do you know any other very similar, projects to the RAGBuilder that people can also start using? I think there was one. Was it Auto RAG? Was it?
Yes, there is Auto RAG. I believe it's very similar to the RAGBuilder. I believe that RAGBuilder's interface is one thing that just gives it a little bit of an edge. The UI is something that makes it very simple for anybody to join the RAG building environment. Also, the ability to chat whilst in that local host is also something that I'm not sure if AutoRag currently provides. It means that you can easily chat and see what the results are on the fly, rather than maybe having to set up a whole chat interface, the UI for the chat interface, etc. So you can do that whilst on the fly on the local host as soon as you've made those different configurations to see what's the most optimum for you.
Amazing. Well, you've pretty much shown that you can have a RAG framework within 10 minutes. That's spectacular.
Yeah.
All right.
Yeah.
Thank you for coming on and speaking to us today, Toyosi. Well, we're going to wrap up now. So, Tori, over to you.
I clicked the button a bit early. Sorry, Toyosi. I think that's us for this user group. I think the only thing I wanted to remind everyone of before we leave is to join us on Meetup. It's the best way to get announcements of when we're next coming out. Our next one, we tend to run these every 3 months. But we also have the Global AI Bootcamp coming up, which is going to be an in-person event in London. So if you want to keep up to date with all of those events and streams, then it's just worth following us.
Yep. And last thing, right, we're always looking for new speakers to join us and speak on the Global AI London. So if you're interested, just let us know and we'll absolutely be more than happy to schedule you in for the next meetup.
Awesome. Thanks, Gavi. Thanks again to all our speakers and everyone for listening. See you soon.
See ya.